Since the dawn of human existence, mankind has been captivated by the profound and mysterious questions of the cosmos. Among these, one question has resonated throughout history: what lies beyond what we know? This inquiry not only provokes curiosity but stirs a deep sense of wonder and fascination about the unknown. What exists beyond the boundaries of our universe? The answer to this question is incredibly complex and elusive. However, with advancements in modern technology, particularly with the advent of powerful astronomical instruments, we are closer than ever to uncovering some of these cosmic mysteries. One of the most groundbreaking instruments in this quest is the James Webb Space Telescope, JWST. This highly advanced telescope, stationed in the far reaches of space, has made significant discoveries, revealing something massive and intriguing at the farthest edges of the cosmos, something that could potentially revolutionize the field of physics as we know it. But what exactly has the James Webb Space Telescope discovered at the edge of the universe? Why are scientists across the world so electrified by these findings? We invite you to join us on this extraordinary journey, as we delve into the groundbreaking discoveries made by the JWST. This mission has brought us face to face with the furthest limits of what we can observe, pushing the boundaries of our understanding and challenging the very fundamentals of science. If you have a passion for exploring the mysteries of the universe and want to stay updated with the latest news from the cosmos and beyond, be sure to subscribe to our channel. Don't forget to like this video and turn on the notification bell to ensure you never miss an update on these awe-inspiring revelations. The key to understanding the universe and its behavior lies in the theories that have shaped our comprehension of gravity, space, and time. Over a century ago, Albert Einstein, one of the greatest scientific minds in history, formulated the theory of general relativity. This theory dramatically altered the way we perceive gravity, space, and the universe itself. Prior to Einstein's groundbreaking work, Isaac Newton's theory of gravity, developed in the 17th century, had been the dominant explanation of how objects interact with each other in space. However, Einstein's theory of gravity, proposed in 1915, expanded upon Newton's ideas and revealed that gravity was not just a force between objects but the result of the curvature of space-time. The following year, in 1916, Einstein applied his revolutionary theory to the cosmos, unveiling a startling truth: the universe could not remain static. According to Einstein's calculations, the universe was either expanding or contracting, a revelation that would forever change how we viewed the cosmos. Fast forward to 1929, when Edwin Hubble, a pioneering American astronomer, made one of the most important astronomical discoveries of the 20th century. Hubble observed that galaxies were moving away from each other, and this movement was proportional to their distance from us, a phenomenon now known as Hubble's law. This discovery confirmed that the universe was expanding, a direct consequence of the Big Bang, the colossal event that marked the birth of the universe approximately 13.82 billion years ago. This ever-accelerating expansion means that the space between galaxies is continuously increasing, creating a universe that stretches and evolves over time. Theoretical physicists have proposed several possibilities for the ultimate fate of the universe. Some believe that the universe may continue expanding infinitely, growing larger and larger until it becomes cold and desolate. Others suggest that the universe could curve back on itself like the surface of a sphere in a higher dimension, leading to a cyclical nature where it eventually collapses in a big crunch. However, there are also theories that propose the universe has an edge. Since the universe has an age, 13.82 billion years, the light from galaxies that formed shortly after the Big Bang has had a limited amount of time to reach us. This creates a finite region we can observe, known as the observable universe. The observable universe is essentially a cosmic bubble, a spatial sphere centered on Earth with a radius of approximately 13.82 billion light-years. Within this bubble, we can see galaxies whose light has taken less time than the age of the universe to reach us. Yet, the universe is far larger than this observable portion. In fact, recent calculations estimate that the total universe may be about 92 billion light-years across. The limit of our observation is called the cosmic horizon, akin to the horizon seen from the shore of a vast sea. Beyond this cosmic horizon, we know that there are countless galaxies and stars, but their light has not yet reached us, and it may never do so, depending on how the universe continues to expand. This is where the James Webb Space Telescope comes in. Being 100 times more powerful than its predecessor, the Hubble Space Telescope, the JWST is capable of detecting the faintest traces of infrared light emitted from the earliest galaxies that formed after the Big Bang. Its powerful sensors can peer into the farthest reaches of space, capturing data on planets, stars, and entire galaxies, some of which may hold the key to understanding the habitability of other worlds. However, the true potential of the JWST remains to be seen, especially as it is directed toward the very edge of the observable universe. What will it find? What cosmic secrets lie just beyond our reach? The universe is divided into the observable and the unobservable. The observable universe includes everything we can detect by measuring radiation, such as visible light, radio waves, and other forms of electromagnetic radiation. The limit of what we can observe is marked by the cosmic microwave background, CMB, a faint glow of radiation that dates back to 13.8 billion years ago, when the universe was in its infancy. At that time, the universe was a hot, dense fog of particles, and it was opaque to light. As the universe cooled, it became transparent, allowing light to travel across vast distances. Some scientists hypothesized that gravitational waves and neutrinos, subatomic particles that pass through matter almost without interaction, might originate from even farther back in time, from regions of the universe we cannot yet observe. Unfortunately, current technology does not yet allow us to detect these distant signals. Still, cosmologists suggest that to truly understand the universe, we must consider that what we observe is only a fraction of a much larger, more complex reality. For instance, the discovery of extremely distant galaxies like Able 2744y1, which lies at the farthest edge of the observable universe, has provided astronomers with a glimpse into the early stages of galaxy formation. This galaxy, Able 2744y1, is so distant that the light we observe today has taken approximately 13 billion years to reach us. Remarkably, scientists are able to study this galaxy as it existed in its infancy, just 650 million years after the Big Bang. The discovery of this distant galaxy was made possible through the combined efforts of the Spitzer Space Telescope, Hubble Space Telescope, and the Tundra Telescope. Each telescope captures data from different parts of the electromagnetic spectrum, and when their findings are combined, astronomers can study galaxies that lie up to 100 times farther away than what any single telescope could achieve on its own. Astronomers from the Astrophysics Institute in Canada, along with researchers from the University of La Laguna, used these telescopes in tandem to discover Able 2744y1. They employed a technique known as gravitational lensing, a phenomenon in which the gravitational field of a closer galaxy magnifies the light from a more distant one, effectively acting like a cosmic magnifying glass. This allowed astronomers to calculate the distance of Able 2744y1 and estimate the number of stars within it. While this galaxy is small compared to the Milky Way, measuring about 2,300 light-years across, its rate of star formation is astonishing, 10 times higher than that of our own galaxy. Another fascinating discovery comes in the form of DES 16C2NM, an extraordinarily distant supernova. Supernovae are powerful and violent explosions that mark the death of massive stars. When a star exhausts its nuclear fuel, it collapses under its own gravity, leading to a supernova explosion. These explosions are crucial for our understanding of the life cycle of stars, as they scatter heavy elements like iron, gold, and platinum into space, elements that are essential for the formation of planets and life itself. The DES 16C2NM supernova is particularly intriguing because it is classified as a dark supernova, meaning that it emitted very little visible light, making it difficult to detect using traditional telescopes. However, thanks to telescopes capable of observing infrared light, scientists were able to identify this supernova. The discovery, made in 2016 by a multinational team of astronomers, took 5 years and more than 500 nights of observations to confirm. This rare type of supernova occurred about 10.5 billion years ago, and its light has been traveling through space for nearly the entire history of the universe. As the universe expands, the supernova is now much farther away than it initially appears to the naked eye. Supernovae of this magnitude have significant consequences for their surrounding galaxies. The explosion releases immense amounts of energy, in the form of neutrinos and photons, which interact with the surrounding gas and dust, creating a shockwave that travels outward at speeds of thousands of kilometers per second. This shockwave heats up the surrounding material, emitting radiation that can be detected across the electromagnetic spectrum, from visible light to radio waves and even X-rays. The heavy elements created in the explosion are dispersed throughout the galaxy, enriching the interstellar medium and providing the raw materials needed for future generations of stars and planets. By continuing to study these distant phenomena, astronomers are inching closer to uncovering some of the greatest mysteries of the universe. Each new discovery, from galaxies like Abell 2744Y1 to supernovae like DES 16C2NM, provides invaluable clues to the evolution of the universe and the intricate processes that govern it. What lies beyond the edge of the universe? While we may never have all the answers, the relentless pursuit of knowledge, driven by tools like the James Webb Space Telescope, brings us closer to understanding the cosmos with each passing day. Let us know what you think lies beyond the observable universe in the comments. And if you enjoyed this journey through the cosmos, don't forget to like the video, subscribe to our channel, and turn on the notification bell to stay informed about the latest news from the universe. Thank you for watching, and we'll see you next time.